What incredible secrets lie behind every planet in our cosmic neighborhood? How can oceans of liquid water hide beneath the ice of our solar system's most distant moons? Dear traveler, welcome. Today we're off to explore our solar system. From the icy confines of Neptune to the infernal heat of Venus, from the blue dunes of Mars to the glittering rings of Saturn, every planet, every moon, every asteroid hides mysteries waiting to be revealed. And every space mission pushes back the limits of our understanding. But before you set off on your next adventure, remember to like the video and subscribe to the channel so you don't miss a thing. Thank you and have a great trip! Imagine a world where temperatures can approach 480 degrees Celsius or 806 degrees Fahrenheit during the day, only to plunge to below minus 180 degrees Celsius or minus 292 degrees Fahrenheit at night. Welcome to Mercury, the closest planet to the Sun. But today we're not interested in extreme heat. Although often overlooked, Mercury hides some incredible secrets, including glaciers. It sounds impossible, but it isn't. Discovered in the chaotic regions of the planet's North Pole, these formations are nestled in cavities caused by meteorite impacts. But they are not water ice as on Earth. These glaciers are in fact layers rich in volatiles, substances such as sodium, sulfur, and oxygen, which at such extreme temperatures would immediately sublimate under the effect of heat. These structures were probably formed billions of years ago when Mercury still had an atmosphere capable of retaining these compounds. Today, with an extremely thin atmosphere, Mercury nevertheless retains valuable traces of these volatiles. Thanks to the MESSENGER probe, which explored the planet between 2011 and 2015, and advanced spectral analysis, these glaciers have finally been detected. And you may be wondering, why is this important? Because not only do these glaciers reveal Mercury's geological history, they also raise the question of the possible presence of conditions conducive to habitability way back when. Fascinating, isn't it? To think that a planet so close to the Sun could preserve such vestiges. Aboard the Bepi-Colombo spacecraft launched in 2018, new revelations are shaking up our knowledge, this time of Mercury's magnetosphere. The spacecraft's ultra-sophisticated instruments are capturing mysterious currents. Strange ring currents of charged particles, ions that swirl around the planet like cosmic ghosts. These phenomena, recorded in 2023, reveal a complex interaction between Mercury and the solar winds it experiences. Unlike the Earth, which has a dense protective magnetosphere, Mercury's is fragile and fragmented. Yet it manages to capture some of the Sun's energetic particles, creating hollows on the planet's surface. Thanks to onboard instruments such as the MPO MAG dual magnetometer, researchers were able to obtain data on these interactions. They realized that Mercury, despite its small size and weak magnetic field, is in fact much more active than expected. Hollows, observed for the first time by the MESSENGER mission, continue to form as a result of the sublimation of volatiles. It's a veritable balancing act between the scorching heat and the invisible forces of the solar wind that constantly sculpt this strange world. From ancient salt hidden in its frozen hollows to a magnetic dance with the Sun, these two discoveries, made thanks to missions such as MESSENGER and Bepi-Colombo, show us just how much more complex and fascinating Mercury is than it seems. After traveling so close to the Sun, let's turn our gaze to another planet, Venus. Often referred to as Earth's twin sister due to its size and rocky composition. But beneath its golden veil, Venus hides many secrets. And one of the most fascinating was revealed a handful of years ago. In 2020, a team of researchers led by Jane Greaves made a discovery that set the scientific community ablaze. Traces of phosphine in the thick layers of Venus's atmosphere. Phosphine is a chemical compound generally associated with biological processes. On Earth, this molecule is produced by certain microorganisms in oxygen-free environments. So why is it found in the clouds of Venus, a planet with temperatures and pressures worthy of a chemical hell? Instruments at the James Clerk Maxwell Telescope in Hawaii and the ALMA Observatory in Chile have detected this molecule at an altitude of around 50 kilometers, or 30 miles. This is where conditions are relatively more temperate, compared with the planet's infernal surface. What's intriguing is that phosphine shouldn't be able to persist in these atmospheric conditions unless something unexpected happens. Intense volcanic activity, unknown chemical reactions, or perhaps the presence of extraterrestrial microorganisms? This discovery is just the beginning. For while it suggests biological activity, it also raises questions. What if life as we know it could survive in these extreme conditions? Future flybys of Venus, including those planned by NASA's Veritas and Da Vinci Plus missions, could well unlock the secrets of these toxic clouds. In the meantime, the smell of phosphine hangs over Venus like a chemical enigma, waiting to be solved. Having explored the toxic clouds of Venus, it's time to travel to a planet that has been the stuff of human dreams for decades: Mars. Why Mars, you may ask? Because this planet has continued to reveal its secrets in recent years. Thanks to the many missions sent out by NASA and other space agencies, Mars has become the scene of a series of extraordinary discoveries. But one of the most striking discoveries dates back to 2018, when scientists detected the presence of an underground lake beneath the South Polar Cap. This revelation, published in the journal Science, is the result of data collected by the Marsis radar aboard the European Space Agency's Mars Express probe. This body of water measures around 20 kilometers or 12 miles wide and lies approximately 1.5 kilometers or 1 mile below the frozen surface. The water is thought to be kept liquid by perchlorate salts, which lower its freezing point. But what does this discovery mean? Well, the existence of liquid water on Mars fuels theories about the possibility of microbial life. If this underground water could contain traces of past or present life, it would totally upend our understanding of the red planet. As rovers like Perseverance continue to search the Martian surface, the promise of discovering ancient, or why not, present-day life forms becomes ever more credible. Let's stay a moment longer on Mars. This planet not only has underground lakes, it's also showing signs of vibration. In 2019, NASA's InSight mission detected for the first time a phenomenon that was previously unknown to us: Mars tremors or Mars quakes. InSight, which stands for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport, was designed to study the depths of Mars. In April 2019, thanks to its ultra-sensitive seismometer, called SEIS, it picked up a seismic signal never before observed. This first Marsquake of low magnitude was proof that Mars, although geologically less active than Earth, is not a fixed planet. Since then, InSight has detected several hundred of these tremors, some of them powerful enough to indicate more complex internal activity than expected. These tremors are of the utmost importance in understanding the internal structure of Mars, its geological layers, and perhaps even its ancient tectonic plates. By studying these seismic waves, scientists hope to discover what lies beneath the surface, and thus better understand the formation of rocky planets. As we continue our exploration of Mars, let's look up at an unexpected sight. Mars hasn't just revealed desert landscapes and red mountains. In 2020, another discovery lit up the Martian sky in a way invisible to our eyes: an infrared aurora. Instruments on NASA's MAVEN spacecraft, which has been orbiting Mars since 2014, captured this phenomenon invisible to humans. This aurora, quite different from the aurora borealis we experience on Earth, manifests itself as a discrete glow, detectable only by infrared sensors. Unlike terrestrial aurorae, caused by interactions between the magnetic field and solar particles, those on Mars result from the impact of the solar wind with an atmosphere that lacks significant magnetic protection. The result? Infrared eruptions, especially visible at night in the planet's lower latitudes. This aurora is essentially composed of carbon dioxide emissions, a gas abundant in the Martian atmosphere. These manifestations provide new information on how the solar wind interacts with the thin Martian atmosphere. But they are also an indicator of the slow disappearance of this atmosphere over time, a key element in understanding the red planet's climatic evolution. In 2021, NASA's Curiosity rover, which has been roaming the Martian soil since August 2012, captured fascinating images of bright clouds floating in the red planet's atmosphere. These clouds, observed at high altitudes, proved to be hypnotically beautiful, forming shimmering patterns in the cold Martian sky. Although ice clouds are common on Mars, these specific formations, observed particularly at the start of the Martian year, are higher than normal, at around 60 kilometers altitude. Unlike the usual water clouds, these are composed of carbon dioxide crystals. But what makes them even more impressive is their pearly brilliance in the Martian sunset, a phenomenon similar to the pearly clouds on our own Earth. Curiosity revealed not only their rarity, but also their diversity. Some clouds resembled fine wisps, others veritable sparkling waves. Their brilliance is particularly enhanced when the sun sets, producing a spectacle worthy of the most beautiful terrestrial twilights, a scene never seen before on Mars. These observations open a window onto Martian meteorology and suggest that even an arid cold planet can still surprise with its atmospheric phenomena. The light reflected by these ice crystals in the thin atmosphere creates a striking contrast with the dusty red surface of Mars, as if the planet itself still holds luminous secrets, yet to be revealed. In February 2021, it was the turn of the Perseverance rover to mark another historic moment by successfully landing on Mars. Designed for an ambitious mission, this astromobile, weighing over a ton, aims to explore one of the red planet's most promising regions, the Jezero crater. But it's not just a simple landing. Perseverance carries with it cutting-edge technology, ready to search for signs of ancient life and pave the way for the future of Martian exploration. Equipped with a robotic arm and a series of revolutionary instruments, the rover's main mission is to collect soil and rock samples. These samples could be the first to return to Earth on future missions, enabling scientists to carry out in-depth analysis of their composition. Perseverance is also the first rover to test oxygen production on Mars, thanks to the MOXIE instrument, which extracts oxygen from carbon dioxide in the atmosphere. What makes Perseverance even more special is that it carries a unique passenger, the Ingenuity helicopter, the first to fly on another planet. With its first successful flights in April 2021, Ingenuity has proved that controlled flight on an extraterrestrial planet is possible, paving the way for future aerial missions. Perseverance is not only a pioneering rover, it also marks the beginning of a new era in Martian exploration. It could well be the source of discoveries that will transform our understanding of the universe as a whole. But let's return to recent observations, some of which are proving most intriguing. At the south pole of Mars, unique geological formations, dubbed Martian spiders, have fascinated scientists since their discovery. In 2021, a study published in the Planetary science journal provided new data on these mysterious structures. These spiders are not extraterrestrial creatures, but formations caused by the interaction between CO2 ice and the Martian surface. During the Martian winter, frozen carbon dioxide accumulates as ice in the polar regions. When spring arrives, the ice sublimates directly into gas under the effect of the sun, but remains trapped under a layer of transparent ice. This accumulated gas eventually builds up such pressure that it violently escapes through cracks, eroding the ground and forming these intricate spiderweb-like patterns. These formations, scientifically characterized as areniiform, exist nowhere else in the solar system. Their appearance is therefore a direct testimony to the unique dynamics of the carbon dioxide cycle on Mars. Scientists are studying these phenomena to better understand the Martian polar climate, and in particular, how these erosion processes might affect the surface over time. Mars continues to amaze us with its extraordinary landscapes and natural phenomena. These mysterious South Pole spiders only add to the long list of enigmas this planet continues to present. On Mars, on the heart of a desert landscape, lies a sight as beautiful as it is unexpected: an immense sea of blue dunes. Observed by NASA's Mars Reconnaissance Orbiter in 2022, this expanse of dunes stretches almost 30 kilometers, or 19 miles wide, in the mid-latitude region of the Northern Hemisphere. These bluish dunes are actually the result of an optical effect. Their hue is a false blue generated by infrared filters used to accentuate contrasts in images. In reality, the Martian sand that makes up these dunes is made up of fine particles of dark basalt, a volcanic material common on Mars. Color variations are due to differences in surface temperature and material composition. The lighter areas often seen around the dunes are composed of finer wind-blown dust. However, the scientific interest of this sea of dunes goes beyond its visual beauty. Researchers are studying these formations to better understand the dynamics of Martian winds and the erosion processes that sculpt these landscapes. The dunes of Mars move slowly under the effect of constant winds, offering a glimpse of the planet's geological and climatic activity. This Martian landscape, with its waves of blue sand contrasting with the surrounding reddish rock, is a window onto a world both familiar and alien. The red planet continues to reveal its treasures, and each image of this sea of bluish dunes is a step closer to understanding its present and past climate. In 2022, while the Perseverance rover was exploring geologically rich terrain in the Jezero crater, a strange discovery caught the attention of scientists: a spaghetti-shaped object suspended from the Martian surface. This unusual image immediately raised many questions. But before the imagination gets carried away, the likely explanation is more technical. It's probably debris from the mission itself. Researchers believe that this object, resembling a twisted filament, could be a piece of rope or a fragment of Perseverance's landing system. The debris may have come from the parachute or other equipment used during the rover's descent in February 2021. When it comes to space innovation, Mars is now the scene of some real technical feats. Ingenuity is the most striking example. It is the first helicopter to fly on another planet. Deploying in 2021, this small drone weighing just 1.8 kilograms or 4 pounds has conquered the Martian skies by accomplishing what once seemed impossible: flying in an extremely thin atmosphere. The feat is all the more incredible given that Mars has only a tiny percentage of the Earth's atmospheric thickness, making high-altitude flight extremely difficult. Initially scheduled for a series of 5 flights, Ingenuity has continued to push its limits well beyond expectations. By 2023, it had already completed more than 50 flights, covering kilometers and capturing breathtaking images. Its role now goes beyond mere technological demonstration. It actively assists the Perseverance rover in its search for promising locations to explore. In particular, the aerial images provided by Ingenuity enable scientists to analyze terrain inaccessible to the rover. Also in 2023, surprising news shook up our knowledge of Mars: the discovery of water ice at the planet's equator. This region, usually considered too hot to hold water in solid form, revealed pockets of ice buried beneath the surface. Thanks to the instruments of the Mars Odyssey mission and the study of radar data from the Mars Reconnaissance Orbiter spacecraft, scientists were able to locate this precious resource. While this discovery is important for understanding the geological processes on Mars, it is even more important for the future of human exploration. Indeed, the presence of water, even in its icy state, is crucial to the colonization of Mars. It could be used not only for drinking, but also and above all, to generate oxygen and fuel. The possibility of drawing on these ice reserves at the equator, a region milder in terms of temperature than the poles, could facilitate the future installation of human bases. What was once a dream is now a real possibility. Mars could one day be home to human colonies, able to live off its own resources. In short, the Martians we might come across one day would simply be expatriate Earthlings. The discovery of ice at the equator paves the way for viable human exploration, bringing the dream of walking on the red planet a little closer. In fact, she seems to be sending us a sign that expresses, in a way, an agreement on her part. On Mars, even the ground seems to play tricks on our eyes. In 2023, an image captured by the European Space Agency's Mars Express probe revealed an intriguing rock formation resembling a smiling face. This phenomenon, known as pareidolia, is a psychological effect moment in which our brains recognize familiar faces or shapes in objects or landscapes. In this case, the rugged terrain and depressions of this Martian region have, with light and shadow, formed a smiling figure, seemingly observing the exploration missions from the surface. While this image is first and foremost a visual curiosity, it also reminds us just how much Mars, with its multiple landscapes and rock formations, can arouse our imagination. Pareidolia is nothing new on Mars. It takes us back to other famous discoveries, such as the famous face observed in the Kydonia region in 1976. In the same year, 2023, a fascinating atmospheric phenomenon was observed by the European Space Agency's Mars Express probe. A gigantic mushroom-shaped cloud stretching over Arsia Mons, one of the highest volcanoes on Mars. The cloud is actually a water ice cloud, formed by the interaction between Martian winds and the specific geography of the region. Scientists have identified this phenomenon as an orographic cloud, a type of cloud that forms when moist winds encounter a mountain or volcano and are forced to rise. At high altitude, the air cools and water vapor condenses, creating this gigantic ice cloud. Unlike terrestrial clouds, those on Mars are much thinner, due to the low atmospheric density. Although surprising at first glance, these clouds provide clues about Martian meteorology and the interactions between the atmosphere and the surface. Every observation of this kind helps us to better understand the water cycle on Mars and to predict future weather conditions. These forecasts will be much needed when the time comes to plan manned missions. Seeing this majestic cloud rise up into the Martian sky is amazing. But above all, it reminds us that even on a cold, arid planet, fascinating atmospheric processes continue to shape its environment. After exploring the promising planet Mars, our journey takes us through the asteroid belt. These mysterious wanderers of space orbit mainly between Mars and Jupiter. From their chemical composition to their potential impact on the Earth, asteroids are at the heart of much exciting scientific research. Our next step takes us to the largest asteroid in our solar system, hence its designation as a small dwarf planet, the smallest in our stellar neighborhood. This is the famous Ceres. Discovered by NASA's Dawn mission, these gleaming zones are mainly located in the Kuiper crater. Initially, their exact nature was unknown, but in-depth studies have revealed that they essentially contain sodium carbonate, a compound of sodium, carbon, and oxygen. These shiny deposits probably originate from salt water that has oozed to the surface before evaporating, leaving behind a highly reflective salt crust. Research has shown that this salt water comes from a deep reservoir of brine located beneath Ceres' crust. This reservoir, around 40 kilometers or 25 miles deep and extending for hundreds of kilometers, bears witness to the dwarf planet's past geological activity. The recent discoveries published in Nature Astronomy in 2020 confirm that Ceres is a water-rich world, similar to certain icy moons in the outer solar system. This is reminiscent of Europa, Ganymede, and Enceladus, moons that are also home to mysterious oceans. As we leave Ceres and its mysterious bright spots, we move on to asteroid 16 Psyche. Orbiting this unique celestial object, we discover a metallic world shining like a jewel in the darkness of space. Psyche, at 226 kilometers or 140 miles in diameter, is no ordinary asteroid. Long thought to be the remnant core of a protoplanet, it still holds many surprises in store. In 2019, a team of astronomers led by Tracy Becker of the Southwest Research Institute made a stunning discovery. Using the Hubble Space Telescope and its ultraviolet imaging technique, the scientists detected telltale signs of water, or hydroxyl, on the surface of Psyche. This unexpected observation was published in the astrophysical journal Letters in October 2020. For researchers, once again, this discovery is an enigma. How can water persist on a metallic world? Scientists believe these molecules could have come from Psyche being bombarded by charged particles from the solar wind, interacting with the minerals on its surface. Alternatively, impacts by small asteroids rich in carbon and water could have deposited this volatile material. This discovery raises fascinating questions about the history of Psyche and the processes that shape celestial bodies. If water can survive on a metallic world, what other surprises await us in the unexplored recesses of our solar system? The importance of this revelation is not limited to pure science. The presence of water on Psyche could have major implications for future space exploration and asteroid mining. NASA, recognizing Psyche's extraordinary potential, has scheduled a dedicated mission. The Psyche spacecraft, launched in October 2023, is scheduled to reach the asteroid in 2029. Equipped with sophisticated instruments, it will scan the asteroid's surface, map its composition, and seek to unravel the mysteries of its formation. Leaving the enigmatic Psyche behind, we now turn our attention to another fascinating object in our solar system, Asteroid 216 Cleopatra. This asteroid, whose silhouette stands out clearly against the starry background, is one of a kind. At 217 kilometers, or 135 miles long, and 94 kilometers, or 60 miles wide, Cleopatra looks strangely like a gigantic dog bone floating in space. This irrational shape, long suspected, was confirmed in 2021 thanks to state-of-the-art observations. An international team of astronomers, led by Frank Marchus of the SETI Institute, used the European Southern Observatory's Very Large Telescope in Chile to obtain the most detailed images ever taken of Cleopatra. These observations, published in Astronomy and Astrophysics in September 2021, revealed not only the precise shape of the asteroid, but also fascinating details about its composition and history. Cleopatra isn't just remarkable for its appearance. This asteroid is also a triple system, orbiting the Sun accompanied by two small moons, named Alex Helios and Clio Selene, after the children of Queen Cleopatra. These satellites, discovered in 2008, add further complexity to this already extraordinary system. Cleopatra's unusual shape raises many questions about its origin and evolution. Scientists believe it could be the result of a massive collision in the distant past, followed by a reassembly of the debris under the effect of gravity. This hypothesis would explain not only its strange shape, but also its predominantly metallic composition, with a surprisingly low density for an object of this nature. The new observations have also enabled researchers to refine estimates of Cleopatra's mass, revealing that the object is around 35% less dense than previously thought. This discovery suggests that the asteroid may have a porous internal structure, resembling a pile of rubble held together by gravity. Leaving the asteroid belt behind, we head for Jupiter, the largest planet in our solar system. In 2016, NASA's Juno probe entered orbit around this planet, marking the start of a scientific adventure that continues to challenge our knowledge. Since its arrival, Juno has revealed some fascinating secrets about Jupiter, most notably in 2018, when scientists discovered that its atmospheric jets extend much deeper than expected. Unlike terrestrial jet streams, Jupiter's plunge thousands of kilometers below its surface. This has totally altered our understanding of Jupiter's atmosphere, where colossal meteorological phenomena, such as the famous Great Red Spot, have been at work for centuries. Imagine hovering above these gigantic cyclones for a moment, feeling their power and permanence in this gaseous world devoid of palpable ground. But Juno is not limited to the study of Jupiter itself. In 2023, the probe captured striking infrared images of the planet's polar cyclones, massive phenomena that rage at the poles and still remain largely mysterious. It has also begun exploring Jupiter's icy moons. It has revealed surprising details about their surfaces and potentially underground oceans, such as those of Europa, a moon where hopes of finding microscopic life forms persist. Thanks to Juno, Jupiter is no longer just a distant, mysterious giant. It's a dynamic, complex world with a living atmosphere, incredible climatic phenomena, and moons that could well hold the keys to life. Did you see it? Our cameras have detected an intense flash of light. These fleeting flashes that illuminate the upper layers of the atmosphere were first observed on this planet in 2020. Researchers call them sprites. These transient light events seen here on Earth during violent storms are even more impressive thousands of kilometers above Jupiter's clouds. These mysterious flashes emerging from Jupiter's stormy depths resemble bluish explosions, visible for only a few milliseconds. Scientists were able to detect them thanks to the Juno probe, which observed these phenomena using instruments capable of capturing ultraviolet light frequencies. A spectacle as violent as it is ephemeral, where the beauty of the elements meets the immensity of space. But Jupiter's surprises don't stop there. Let's step outside its atmosphere. There, floating in infinite space, we can catch a glimpse of its many natural satellites. Indeed, in 2018, astronomers made a fascinating discovery. No fewer than 12 new moons have been identified around the giant planet. A further 12 new moons were announced for 2023. Jupiter now has 92 known moons. Among these new satellites, one in particular is intriguing scientists. Nicknamed the Oddball, this moon with its chaotic orbit seems to defy the usual laws of motion of Jovian moons. Unlike its companions, it follows a retrograde trajectory, which could indicate that it was captured by Jupiter's gravitational pull at some point in its system's history. Observing these small, distant, and mysterious moons, crossing the vast icy expanses of space under Jupiter's diffuse light, it's easy to get lost in the immensity. The ballet of these satellites offers a silent spectacle, a graceful dance around a giant whose gravitational force seems to reign over all that surrounds it. Our journey around Jupiter would not be complete without a stopover on Ganymede. As well as being Jupiter's largest natural satellite, Ganymede is also the most imposing of all the satellites in our planetary system. With a diameter of 5,268 kilometers, or 3,300 miles, Ganymede exceeds Mercury by 8%, and Saturn's largest moon, Titan, by 2%. It turns out that in 2015, observations made by the Hubble telescope revealed an incredible discovery. Ganymede could harbor a deep underground ocean beneath its icy crust. This hidden body of water could even contain more water than all the Earth's oceans combined. Scientists believe that this ocean lies between two layers of ice, in a kind of frozen sandwich that could protect the water from radiation. Beneath this thick crust of ice, in total darkness, the water could be in contact with rocky material, potentially creating the right conditions for the emergence of life. If this proves true, Ganymede would become one of the most promising places in our solar system to harbor extraterrestrial life. Our attention now turns to Europa, another of Jupiter's iconic moons. This moon, with its fascinating streaks of ice, has intrigued scientists for decades. In fact, in 2022, a major discovery was announced. Ice geysers were observed spouting from its surface, projecting water vapor hundreds of kilometers into space. For a long time, scientists suspected the existence of these plumes of water. Thanks to Hubble and other instruments, it has now been confirmed that Europa is not just an icy moon. These geysers, veritable columns of ice rising into the stellar void, could well indicate the presence of a liquid ocean beneath the moon's surface. As with Ganymede, there's nothing far-fetched about this hypothesis. The tidal forces exerted by Jupiter could well heat up this ocean, even if it were covered by a thick frozen mantle. Imagine the pressure and heat under this thick layer of ice, where trapped water finds an outlet in the form of spectacular geysers. The idea that hidden oceans exist beneath such icy surfaces raises huge questions. Could there be life forms evolving in these icy depths? Future missions, such as the Europa Kuiper probe, could well answer this question and forever change our perception of habitability in the universe. We could even unravel the mysteries of these subterranean oceans. Leaving the fascinating moons of Jupiter behind, we head for majestic Saturn. Here we are above this cosmic jewel, a planet that fascinates not only by its rings, but also by its enigmatic atmospheric phenomena. One of the most intriguing is directly at the North Pole. It's a gigantic hexagon of clouds over 30,000 kilometers or 18,600 miles in diameter, first discovered by the Voyager probe in the 1980s. But it's not just its geometric shape that defies logic, it's also its mysterious behavior. In recent years, researchers have observed that the hexagon gradually changes color. From bluish hues, it has turned golden yellow, a transformation that has baffled scientists. They suggest that this change could be due to Saturn's changing seasons. As the planet approaches its summer solstice, haze particles generated by sunlight accumulate in the atmosphere, altering the hue of this immense polar vortex. Admiring this mysterious hexagon, you can observe this geometric ballet in the Saturnian sky. Its near-perfect structure seems to defy natural laws, and every minute spent contemplating this phenomenon gives you the impression of being face-to-face with an unfathomable cosmic mystery. What forces shape this almost hypnotically moving hexagon, and why is such a phenomenon found nowhere else in our solar system? As we penetrate the depths of Saturn's atmosphere, another surprise awaits us. In 2018, a most unlikely discovery was revealed. Tiny nanodiamonds are said to form at the heart of the giant planet's titanic storms. These precious particles, no larger than grains of dust, are said to form from complex reactions that take place in Saturn's upper atmosphere, where methane is subjected to intense pressure and temperature. Invisible to the naked eye, These nanodiamonds are created in processes similar to those that form diamonds on Earth, but on a much smaller scale. In the heart of Saturn's massive storms, methane is broken down into pure carbon, and under extreme pressure, this carbon assembles to form tiny diamond crystals. I leave it to you to imagine millions of these tiny gems falling like rain through the planet's thick, hazy atmosphere. This phenomenon, which has also been supposed to occur on Jupiter and Neptune, shows us just how exotic these gas giants really are. Data collected by probes such as Cassini have made it possible to detect these traces of nanodiamonds, further proof that Saturn holds wonders as yet unknown. Beyond this breathtaking atmosphere, Saturn's famous rings, as breathtaking as ever, are about to reveal one of their most intriguing phenomena. As you contemplate these jewels, you might think that nothing moves, that everything is frozen in motionless perfection. And yet, structures, fingerprint-like shadows, hence the name spoke, mysteriously appear and disappear within the rings themselves. First spotted in the early 1980s by the Voyager 1 probe, these strangenesses continue to baffle scientists. Although they were subsequently observed by the Cassini mission, it was the Hubble Space Telescope that revealed their most beautiful images in 2023. These spokes, like dark bands, move across the rings, disrupting their smooth, shiny structure. They are thought to be linked to the interaction of ring particles with Saturn's magnetic field. Like a magnet that attracts metal dust, Saturn seems to influence the distribution of matter in its rings, creating these enigmatic rays. This phenomenon seems to be linked to Saturn's seasons, becoming more visible as the equinox approaches, when sunlight strikes the rings at a different angle. But why do these structures appear cyclically, and what is their true nature? Let's leave majestic Saturn and its rings behind and delve into the secrets of one of its most intriguing satellites, Enceladus. Beneath its frozen, cracked surface lies a fascinating secret that scientists unearthed in 2014. Get ready to plunge into the depths of this mysterious world. It was the Cassini probe, faithful explorer of the Saturnian system, that detected something extraordinary. Its ultra-sensitive instruments picked up minute variations in Enceladus's gravitational field. These subtle perturbations revealed the presence of a vast expanse of liquid water beneath the icy crust of the South Pole. This hidden ocean, like an immense subterranean sea, some 10 kilometers or 6 miles deep, is said to extend beneath a 40-kilometer or 25-mile thick layer of ice. I leave it to you to imagine the secret such a reservoir could hold. From a simple icy satellite, it has become one of the most promising places in our solar system to harbor extraterrestrial life. Liquid water, organic compounds, a source of energy. All the ingredients are there for the birth and maintenance of life as we know it. But what could lurk in the dark depths of this extraterrestrial ocean? Microorganisms floating in the currents? Bioluminescent creatures brightening up the abyss? Or perhaps totally new forms of life, defying our understanding? Let's leave the mysterious depths of Enceladus's subterranean ocean behind us and rise to its surface. There, a breathtaking spectacle awaits you, a cosmic ballet that defies the imagination. Imagine flying over the South Pole of this icy moon. Suddenly, you see jets of ice and water vapor hurtling into space like titanic geysers. These gigantic, majestic plumes rise hundreds of kilometers above the surface, forming an ethereal veil that envelops Enceladus in a mystical aura. Scientists still seeking to unlock the secrets of this fascinating world have recently made some astounding discoveries. Thanks to state-of-the-art instruments, they have been able to observe these geysers with unequaled precision. What they discovered surpassed all expectations. These jets are not mere columns of ice and steam. They are alive, pulsing to the rhythm of Saturn's tides. Like the beating of a cosmic heart, their intensity varies according to a complex cycle, a celestial dance orchestrated by gravity. At the heart of these plumes, researchers have detected complex organic compounds, the building blocks of life, projected from the depths of the hidden ocean. Even more fascinating, recent observations suggest that some of these geysers may be interconnected, forming a complex network of channels beneath the icy surface. Let's leave the fascinating geysers of Enceladus behind and venture to another of Saturn's extraordinary moons, Titan. Prepare yourself for a journey that defies imagination, above a world where time itself seems to dance to the rhythm of the seasons. Fly over Titan, a giant moon shrouded in a thick orange atmosphere. Before your eyes, an alien landscape unfolds, alternating between vast expanses of dunes, lakes, and seas, but not as you're used to seeing them on Earth. Thanks to the Cassini mission and ground-based observations, scientists have discovered that Titan undergoes spectacular seasonal changes. Like on Earth, these seasons are caused by the tilt of Saturn's rotational axis, but they last much longer, around 7 Earth years each. As the seasons change, you'll be able to observe some fascinating phenomena. In the northern hemisphere, as spring arrives, clouds form and dissipate, bringing rains of liquid methane. This precipitation feeds hydrocarbon lakes and seas, modifying their level and composition. Even more surprisingly, researchers have detected magical islands appearing and disappearing in these methane seas. Could these be gas bubbles rising up from the depths? Or perhaps floating structures formed by complex organic compounds? In the southern hemisphere, the arrival of autumn is accompanied by a gradual cooling of the atmosphere. This temperature change leads to the formation of a polar hood, a dense haze that spreads over this region, radically altering its appearance. In addition, the winds on Titan also change direction with the seasons, influencing the formation and movement of organic sand dunes that cover vast equatorial regions. It's as if Titan's entire face is changing over time. These latest observations give us a better understanding of this moon, which in many ways resembles a primitive, frozen version of our Earth. Who knows what other secrets Titan still holds in store for us? Let's leave Titan's fascinating seasons behind and venture even further into the solar system. Our imaginary ship hurtles through space, crossing millions of kilometers in a matter of moments, until it reaches a mysterious ice giant, Uranus. We float above this pale blue-green planet tilted on its axis. Suddenly, a dazzling spectacle unfolds before your eyes. Infrared aurorae dance in Uranus's upper atmosphere, invisible to the naked eye, but revealed by our most sophisticated instruments. These auroras, unlike those on Earth, are not green or red, but emit a ghostly glow in the infrared. They tell the fascinating story of the interaction between Uranus's complex magnetic field and the solar wind. Like an ethereal veil, they undulate and swirl, creating hypnotic patterns that defy our understanding. Scientists believe that these aurorae may play a crucial role in heating Uranus's upper atmosphere, explaining why it is much warmer than established models predict. Uranus, that enigmatic planet so similar to our nearest neighbors, still seems to want to keep its secrets. As the aurora of Uranus continues its silent dance, our curiosity pushes us even further. Hold on tight, because we're about to plunge to the farthest reaches of the solar system, where another ice giant awaits us, decked out in its deep blue mantle. You're now in orbit around Neptune, the last of the giant planets, sentinel of the outer reaches of our solar system. Its intense blue captivates your gaze, but it's not its only peculiarity that fascinates scientists. Recently, researchers made a sensational discovery. Neptune's winds, once considered the fastest in the solar system, appear to be slowing down in unexpected ways. These bright white clouds are moving against a deep blue background, but at a different pace than previously thought. The slowing of the winds raises many questions. Is it linked to seasonal variations on Neptune, where each season lasts more than 40 Earth years? Or is it a sign of deeper changes in the planet's atmospheric dynamics? After observing Neptune's mysterious winds, our journey takes us to the farthest reaches of the solar system, within the Kuiper belt. Here, a fascinating and mysterious dwarf planet also has a few surprises in store for us. This is Pluto, yet another icy world waiting to reveal itself. Since 2015, thanks to NASA's New Horizons probe, we've discovered a planet that's far more dynamic than we ever imagined. It turns out that nitrogen glaciers are slowly moving across its surface, sculpting landscapes as strange as they are beautiful. These movements reveal ongoing geological activity, a sign that Pluto is far from being a dead planet. In 2021, scientists identified what could be a super cryovolcano, a mountain of ice spewing out frozen material. This find gives us a glimpse of Pluto's interior, suggesting a rich and complex composition. In addition, Pluto's atmosphere, composed mainly of nitrogen, gently escapes into space, creating a mysterious haze. Dark organic compounds fall from the sky, adding a touch of mystery to this already enigmatic world. And what about the methane dunes discovered in 2018 that stretch for miles? Our journey now takes us to even more fascinating horizons. Beyond Pluto, far beyond the familiar confines of our solar system, lies a little explored world, Quasar. In the dark immensity that surrounds us, this dwarf planet reveals itself, while its ring slowly takes shape, subtle and mysterious. In the face of such a spectacle, one can almost feel the vertigo provoked by the infinite depth of space and the hidden beauty of its remote regions. In 2023, a surprising discovery was made around this dwarf planet in the Kuiper belt. Using ground-based telescopes and the European Cheops satellite, astronomers revealed the existence of a ring surrounding Quasar, an unexpected phenomenon at this distance and under these conditions. What makes this discovery so exciting is that the ring lies well beyond what is known as the Roche limit. This limit marks the theoretical zone where such structures are supposed to disintegrate to form moons. Yet the ring remains stable, defying the laws we thought we had mastered. This phenomenon could lead us to reassess how celestial objects form and interact in the icy regions of our solar system. The Quasar ring is relatively thin, composed of ice and rock particles. Although this object is much smaller than the gas giants, it joins Saturn, Uranus, and Neptune in the select club of bodies with rings. Such discoveries challenge our understanding of trans-Neptunian objects, which appear to be far more dynamic than previously thought. Our odyssey through the solar system now leads us to an extraordinary encounter between human ingenuity and the primordial remains of our cosmic neighborhood. Welcome to the epic journey of OSIRIS-REx and its rendezvous with the asteroid Bennu, an adventure that pushes back the frontiers of space exploration. High-resolution images captured by the OSIRIS-REx space probe reveal a fascinating alien landscape. The surface of Bennu, far from being smooth, is a chaos of rocks and crevices. This unexpected roughness forced the engineers to rethink their sampling strategy, demonstrating once again the remarkable adaptability required of all space exploration. Because, as you will have gathered, the OSIRIS-REx probe didn't just observe. On October 20th, 2020, in a surgically precise maneuver, the spacecraft grazed Bennu's surface for just 6 seconds, long enough to suck in precious samples. This cosmic collection represents a fantastic technical feat, achieved millions of kilometers from Earth. On September 24, 2023, a capsule plunged into the Earth's atmosphere, carrying this priceless treasure. Fragments of Bennu, more than just a stone, an indisputable witness to the birth of our solar system. This collection of dust and rock, plucked from the asteroid's surface 2 years earlier, marks the culmination of a 7-year journey of over 6.21 billion kilometers. But OSIRIS-REx is more than just a mission to collect samples. This ambitious and successful project revealed the secrets of Bennu, an asteroid some 500 meters in diameter, orbiting the Sun every 436 days. Among the most intriguing discoveries are the mysterious erratic boulders dotting its surface. A study of these erratic blocks, published in the Journal of Geophysical Research Planets in 2022, suggests a complex history. Some appear to have been ejected from Bennu's interior, while others may have been impacted by other bodies. This diversity offers a fascinating insight into the processes that sculpt the small bodies of our solar system. Above all, these boulders, some the size of buildings, defy our understanding. How did they get there? Are they the remains of a larger parent body, pulverized in a cosmic collision? Or are they evidence of unsuspected geological activity on asteroids? Whatever the case, the samples brought back, around 250 grams of material, are a time capsule going back to the origins of our solar system. Their analysis promises to revolutionize our understanding of planet formation, and perhaps even the origins of life on Earth. Scientists hope to find complex organic molecules, the building blocks of life as we know it. Let's leave the OSIRIS-REx epic behind and dive into another equally captivating space adventure, the DART mission and its spectacular encounter with the asteroid Dimorphos. Get ready for a story where science fiction and reality merge in a breathtaking demonstration of our ability to protect our planet. On September 26, 2022, at 11:14 p.m., humanity reached a historic milestone in its quest to master the cosmos. That evening, a vending machine-sized craft, launched at the dizzying speed of 6.6 kilometers per second, or 4 miles per second, deliberately crashed into a distant asteroid. The moment, captured live by millions of viewers worldwide, marks the first full-scale test of planetary defense. DART, an acronym for Double Asteroid Redirection Test, was not a simple space probe, but a cosmic projectile designed to alter the orbit of its target. Dimorphos, an asteroid measuring 160 meters, or 252 feet in diameter, orbiting a larger companion named Didymos, was chosen as the ideal guinea pig for this daring experiment. the impact of unprecedented violence released an energy equivalent to that of 3 tons of TNT. In the days that followed, telescopes around the world scanned the skies, watching for the slightest change in the cosmic dance of Dimorphos around Didymos. The verdict came in a few weeks later: a complete success. Dimorphos's orbit had been shortened by 32 minutes, far exceeding scientists' most optimistic expectations. But nature, always full of surprises, still has some fascinating revelations in store for us. Subsequent observations published in the prestigious journal Nature in March 2023 brought to light an unexpected phenomenon. Dimorphos's rotation changed considerably after impact. Imagine a cosmic spinning top, spinning peacefully for millennia. Suddenly, a titanic shock sends it reeling. This is exactly what happened to Dimorphos. Its rotation period, once stable, has lengthened dramatically, from around 7.6 hours to almost 24 hours. Even more astonishing, its axis of rotation has shifted, tilting by almost 10 degrees. This discovery has profound implications for our understanding of impact physics on an astronomical scale. Each asteroid, with its unique shape, composition, and internal structure, could react differently to such an intervention. The DART experiment also offers fascinating insights into the internal structure of Dimorphos. The dramatic change in its rotation suggests that the asteroid could be what scientists call a rubble heap, a loose assembly of rock and dust held together by weak gravity. This structure, common to many small bodies in the solar system, greatly influences their behavior during impacts. Beyond these scientific discoveries, DART represents a crucial milestone in our quest for planetary protection. For the first time, mankind has demonstrated its ability to deliberately alter the course of a celestial object. This feat, which until now was the stuff of science fiction, paves the way for future defense strategies against possible asteroidal threats. Space telescopes such as Hubble, Spitzer, and more recently James Webb play a fundamental role in our understanding of the cosmos. Unlike terrestrial observatories, these devices located beyond our planet's atmosphere are not subject to the latter's interference, such as turbulence or light pollution, offering images of unrivaled clarity. This enables detailed exploration of the planets, moons, and phenomena in our own solar system, revealing crucial data on atmospheric composition, climates, or hidden geologies, such as on Mars, Jupiter, or Saturn. But these telescopes are not limited to our cosmic neighborhood. Looking far beyond, they capture images of exoplanets, fledgling stars, distant galaxies, and phenomena such as black holes. They enable us to study the evolution of the universe over billions of years, and even analyze the chemistry of potentially habitable worlds. These observations open up new perspectives on the formation of stars and planets, and on the possibility of other forms of life in the universe. Probably one of the most fascinating discoveries is that of the TRAPPIST-1 system. First observed in 2017, it is one of the most exciting exoplanetary discoveries of recent decades. Located around 40 light-years from us, this miniature solar system is home to no fewer than 7 rocky exoplanets, all similar in size to Earth. It's thanks to revolutionary tools such as NASA's Spitzer Space Telescope, and more recently, the James Webb Space Telescope, that we've been able to unravel the mysteries of this system. Imagine for a moment this red dwarf star, TRAPPIST-1, colder and smaller than our Sun, around which dance these 7 planets, 3 of which are in the habitable zone. What makes this discovery so exciting is the proximity of the planets to their star. Some complete a full orbit in just a few Earth days. Scientists believe that these worlds, all potentially rich in water, could offer us a valuable clue in our quest for extraterrestrial life. Thanks to James Webb, we soon hope to be able to analyze the atmospheres of these planets in depth, in search of traces of life. To conclude this fascinating exploration of our solar system, the last few months have once again brought their share of astonishing revelations. In May 2024, thanks to collaboration between the English University of Warwick, NASA, and the European Space Agency, an international team discovered Gliese 12b, a potentially habitable exoplanet located 40 light-years from our Earth. Closer to home, in March 2024, the New Horizons probe detected unexpected levels of dust beyond 50 astronomical units, suggesting that the Kuiper belt could extend much further than previously thought. And, as if to remind us that even our closest neighbors keep their secrets, astronomers announced last February the discovery of 3 new moons around Uranus and Neptune. These new objects were detected using advanced imaging techniques from ground-based telescopes in Hawaii and Chile. Future missions such as Europa Clipper and the James Webb Space Telescope will take us even deeper into these unknown worlds. New rovers on Mars, orbiters around icy moons, and even missions targeting asteroids will continue to push back the frontiers of our discernment. Who knows what wonders still await us? Perhaps we'll discover signs of microbial life on a distant moon. Or will precious clues as to how our planet came into being finally be revealed? In reality, the adventurous space exploration is just beginning. More than ever, as we look up at the stars, one question remains: how far will these discoveries take us? However, even if the Earth escapes the various threats of the cosmos, there is one that it will never be able to avoid. And paradoxically enough, it's this very threat that is the origin of life: the Sun. Both creator and destroyer, the Sun has been at the heart of many beliefs throughout human history. Its rays provide the energy needed to warm our atmosphere and enable photosynthesis in plants. Without it, we would never have seen the light of day, literally or figuratively. However, assuming we live another 5 billion years, we cannot escape the tragic end in store for our star. Today, what's known as a yellow dwarf, although ironically its volume is large enough to hold 1.3 million Earths. If our planet were 1.2 centimeters or 0.5 inches in diameter, the Sun would be 1.4 meters or over 13 feet in diameter. Even Jupiter, the largest planet in the solar system, is 10 times smaller by comparison. The Sun alone accounts for 99.86% of the solar system's total mass. And yet, our star is far from having reached its final size. At around 4.6 billion years old, it's estimated to be about halfway through its life. In its interior, nuclear fusion is taking place, resulting in a core temperature of around 15 million degrees Celsius, or 27 million degrees Fahrenheit. This fusion is the source of the Sun's heat and radiation. But like everything else in this world, our Sun is not eternal. The day will come when the Sun will have exhausted all its fuel reserves. It will then begin a slow descent into hell, starting with its expansion into a red giant. At the heart of our star, hydrogen atoms fuse to form helium atoms. This high-energy reaction generates incredible pressure, which tends to expand the star. At the same time, the force of gravity acts to compress the Sun. This balance guarantees the stability of our star. But little by little, the amount of helium in the core increases as the hydrogen is consumed. Eventually, the pressure exerted by fusion will decrease sufficiently to cause the core to contract. This will increase the temperature and pressure in the outer layers of the core. As a result, the hydrogen fusion zone will begin to extend beyond the core, towards the outer layers of the Sun. Hydrogen outside the core will be hot and dense enough to undergo nuclear fusion. Our star will then begin its transformation into a red giant. As the fusion zone expands, the core will continue to contract, while the outer layers of the Sun will begin to expand. Our star will begin to inflate like a balloon. It will first engulf Mercury, then Venus, but the fate of the Earth is less certain. Our planet lies on the edge of the zone where the Sun is set to expand, becoming a red giant. As the Sun expands, its radiation will increase considerably. Its surface will be hotter than before, resulting in increased luminosity. Eventually, the Sun will shed its outer layers into space in the form of solar winds and jets of matter. These expelled layers will form an envelope of gas and dust around the core, creating a planetary nebula. This marks the end of the red giant phase. All that will remain is a dense hot core called a white dwarf, the only vestige of a star that was once resplendent. This white dwarf will be composed mainly of helium and carbon. It will no longer burn fuel, but will continue to glow for a while, emitting residual heat. Then it too will gradually cool down. It will cease to glow and become a dark relic in the darkness of space. In a way, this ending is melancholy sweetness. All the more so when you consider the fate of supermassive stars, which die in a tremendous cosmic explosion called a supernova. All stars and celestial bodies, no matter how immense, will one day come to an end. So before they disappear forever into the sidereal void, let's take advantage of the fact that they are still visible to set off on a voyage of discovery. After starting out in the infinitely small and arriving at the limits of our solar system, it's time for us to go further, much further. Get ready, because we're about to continue our journey into the immensity of our entire universe. Together, we're going to discover the most gigantic objects in the cosmos. In our solar system, we know that Jupiter is the largest of all the planets. Yet across the vastness of our universe and the trillions of billions of galaxies it harbors, there are bound to be stars orbiting a star whose size would make our local giant look like a dwarf planet. Exoplanets so massive, they could be compared to small stars. Well, at the risk of disappointing you, it's unlikely that such planets exist, for the simple reason that too much matter collapses gravitationally, generating sufficient temperature and pressure to trigger nuclear fusion. As a result, what could have become a giant planet often becomes a star. As a result, the largest exoplanets ever discovered are similar in size to Jupiter, although they may be more massive. Such is the case of Kepler 1647b, an exoplanet detected by NASA's Kepler Space Telescope and located nearly 3,700 light-years from us. Its discovery was announced in June 2016, and since then, it has been heralded as the largest exoplanet ever discovered. Its mass and diameter are said to be similar to those of Jupiter. However, Kepler's 1647b has an interesting feature. It is a circumbinary exoplanet. This means it orbits two stars comparable to our own Sun. This particular arrangement of stars is reminiscent of the famous sand planet Tatooine from the Star Wars saga. According to the astronomers' observations, Kepler's 1647b takes around 3 years to orbit this binary system. This is an interesting discovery, as it places the giant in the system's habitable zone. In other words, it orbits at a distance where the appearance of liquid water is likely. However, Kepler's 1647b is a gas planet. It is therefore unlikely to harbor life as we know it. On the other hand, like Jupiter or Saturn, it could have rocky moons, which could then offer much more favorable conditions. Now, if you point a pair of binoculars at the constellation Centauri, you'll be able to spot a young star comparable to the Sun. Located just 310 light-years from Earth, it's called HD 114082. We're not interested in this star, however, but in the exoplanet orbiting it. Named HD 114082b after its star, it is another gas giant. The surprising thing about this star is that its radius is similar to that of our beloved Jupiter. Yet its mass is 8 times greater, some 2,500 times the mass of the Earth. Simply gigantic. Another surprising fact about this super Jupiter, as astronomers call it, is that it orbits very close to its star, about half the distance to the Sun. As a result, its period of revolution is just 110 days. By comparison, Jupiter takes 12 years to orbit the Sun, and Neptune, the most distant gas giant in our solar system, takes 165 years to make a complete revolution. HD 114082b is also the youngest known gas giant whose radius and mass have been determined. But something's not quite right. Based on current models that determine the maximum size and mass that planets can have, our super Jupiter is around 2 to 3 times too dense for such a young gas giant. How can this anomaly be explained? There are several hypotheses. First, it could be that an error was made in the measurements. But with this kind of discovery, the data is always checked several times. Another possibility is that the models used by the astronomers are incorrect. Finally, it's possible that HD 114082b is an anomaly, a kind of cosmic scale error of nature, with an unusually large solid core, which would explain its incredible density. For the moment, the question remains unanswered, and we'll have to wait for further discoveries before we have a definitive answer to this enigma. Speaking of cosmic anomalies, we can also mention the case of AB Aurigae b, also known as ABRB. This is a gas giant exoplanet with a mass 9 times that of Jupiter. This makes it the most massive exoplanet ever discovered. It lies some 508 light-years from Earth. What makes it so spectacular is not just its extraordinary mass. Rather, it's the fact that it's the first directly observed exoplanet still embedded in the disk of gas and dust from which planets are formed. This is known as the protoplanetary disk. To explain the birth of stars, researchers put forward 2 hypotheses. The first is called core accretion. The material making up the disk condenses by accretion until it forms a solid core, essentially made up of rocky materials and metals. Once this core has reached critical mass, it in turn accretes gases, mainly hydrogen and helium, until it forms a gas giant planet. The second hypothesis is that of disk instability. This involves the collapse of parts of the protoplanetary disk under the effect of gravitation. This collapse condenses the material to form a gas-only planet with no rocky core. Given the vast distance separating AB/B from its star, almost 93 times the distance from the Earth to the Sun, astronomers are leaning towards the disk instability model to explain its formation. The shape of the spiral arms of the protoplanetary disks surrounding the star also supports this hypothesis. Having a direct image of AB/B's formation around its star is therefore proof that gas giants can form through disk instability. At least it's an observation that calls into question standard models of planet formation. This is because until now, the vast majority of exoplanets observed had orbits around their stars that did not exceed the distance between the Sun and Neptune. However, AB/B orbits 3 times further than Neptune from the Sun. Unfortunately, it's still too early to say anything about this strange giant planet. In fact, it's only at the beginning of its formation process, rather like a fetus in gestation. It is even approaching the maximum size to be classified as a planet, rather than a brown dwarf. In other words, an aborted star too small to trigger a stable hydrogen fusion process. These stars are halfway between stars and planets, condemned never to shine. Be that as it may, the discovery of AB/B is just further proof of just how complex the mechanisms governing our universe really are. New astronomical observations continually challenge our current theories, improving our understanding of the universe. Planet formation is highly complex and messy, and there are still many surprises in store for us. And we're going to continue our discovery of those surprises. This time, we're going to focus on the telluric planets, i.e. the rocky planets. Just as there are super Jupiters, there are also super Earths, which make our blue planet look like a small moon. One of the most famous of these is HD 219134b. When its discovery was announced on July 30th, 2015, it was the closest telluric exoplanet to Earth ever discovered, just 21 light-years away. But today, that title goes to Proxima Centauri b, which is 4.2 light-years away. That said, HD 219134b is still quite close, and assuming we could ever travel at the speed of light, getting there would not be impossible. However, it's not in its star's habitable zone, so an expedition there seems a bit pointless. All the more so as its surface temperature exceeds 400 degrees Celsius, a veritable furnace. But the reason why HD 219134b is of such interest to scientists is that its proximity allows for a more in-depth study of neighboring telluric planets outside our solar system. Similar to our own planet in terms of composition and density, Super Earth HD 219134b differs above all in its radius and mass. These two parameters are respectively 1.6 and 4.5 times greater than those of the Earth. This may sound huge, but it's nothing compared to the planet that is still considered the most enormous of all rocky planets ever discovered. Its name? Kepler 10c. This exoplanet was detected by NASA's Kepler Space Telescope in 2011. It lies around 560 light-years from Earth in the constellation Dragon. Until then, the telluric planets discovered had masses equivalent to 10 times that of Earth for the largest, but the discovery of Kepler-10c has put things into perspective. This mega-Earth is 17 times more massive than our planet, with a radius 2 times greater. Yet it has the same density. Before its discovery, theorists believed that such planets could not exist. Their argument was that beyond a certain mass, the solid body must capture the surrounding gases, as well as those it produces, to gradually metamorphose into a gas giant. However, this is not the case with Kepler-10c, which remains an enigma for science. In fact, early observations of this star only hinted at its size, so astronomers thought it must be a Neptune-like planet. The surprise came when Kepler-10c's mass was finally measured. Another troubling fact about this star concerns its age. The giant planet is thought to be around 10 billion years old. At that time, the first generation of stars had only just completed their life cycle, and the heavy elements needed to form rocky planets were not very abundant in the universe. Proof that there are certainly worlds similar to our own, but much older in the cosmos. Worlds that could potentially have been home to life for billions of years, giving organisms time to evolve and perhaps even travel to other planets. Although this is purely speculative, it does give us confidence that we may one day encounter other intelligent life forms. Among the bestiary of ultramassive telluric planets, TOI 849b by its scientific name. On NASA's official website, it's presented as a gas giant, yet there's hardly a gaseous envelope to be found on this planet. Only a solid body 3.5 times larger than the Earth, and 40 times more massive. TOI 849b is about the same size as Neptune, but outweighs it by 2.3 times in terms of mass. It is one of the densest planets of its size ever observed. But in reality, TOI 849b doesn't deserve the title of super-Earth, since it is in fact the residual core of a gas giant. TOI 849b could be a reflection of Saturn or Jupiter, should they lose their gas envelope. This hypothesis seems highly likely, given that TOI 849b orbits so close to its star that it circles it in less than a day. It therefore receives 2,000 times more radiation than we do from the Sun. Its gaseous layers may well have been swept away by its star. If this scenario is correct, TOI 849b would be the largest known gas giant core. However, one question remains. If TOI 849b's gas envelope was indeed blown away by its star, how come there's still a residual part of it? Only more detailed observations will one day be able to solve this planetary mystery. Perhaps even telescopes will one day point their sensors at even more monstrous planets, putting astrophysicist models to an even greater test. In any case, if we want to see in detail what the largest objects in the universe are, we can't limit ourselves to planets. We need to go one step further, one step higher, to the stars. Earlier, we saw that within the solar system, nothing compares to the Sun's 1.4 million kilometer diameter. And yet, as imposing as it is in comparison to us, it's just a speck of dust compared to the biggest star we know, Until recently, this record was held by VY Canis Majoris, a red supergiant star in our galaxy 5,000 light-years away. To our eyes, its size seems infinite. 2 billion kilometers in diameter, or around 13 times the distance from the Earth to the Sun. If VY Canis Majoris stood in the place of our Sun, it would be large enough to engulf our solar system all the way to Jupiter. Its size is therefore around 1,500 times that of our star, which in comparison would be no bigger than a football against the Eiffel Tower. But the biggest star we know today is not VY Canis Majoris, but UY Scuti, another red supergiant located in the Sobieski Shield constellation, 9,500 light-years away. 1,700 times larger than the Sun, it could extend as far as Saturn if placed at the center of the solar system. However, when we talk about giant stars, we also need to consider their mass. Indeed, while UY Scuti is the largest of them all, the title of the most massive known star goes to R136A1. It weighs around 250 solar masses, whereas astrophysicists' limits for stars are more like 150 solar masses. What's more, R136A1 is also one of the brightest stars in the cosmos, shining as brightly as 10 million suns combined. Located within the Tarantula Nebula in the Large Magellanic Cloud, a dwarf galaxy close to the Milky Way, its position makes it difficult to observe. In fact, the star is part of the R136 supercluster of stars, 9 of which have a mass more than 100 times that of the Sun. Researchers had to make several measurements and observations to correctly identify all the stars in the R136A group, itself part of the R136 star cluster. Interestingly, R136A1 is located in the Tarantula Nebula, which, as well as being spectacular, is also the largest we know of. It extends over a vast region of space covering some 1,000 light-years. That's around 9.5 million billion kilometers. It's so large that it's even visible to the naked eye from the southern hemisphere. It's even a popular target for amateur astronomers. The Tarantula Nebula is also a cosmic wonder, offering fertile ground for astronomers studying star formation and death. In 1987, a brilliant supernova occurred within the nebula, enabling astronomers to study this prodigious cosmic phenomenon at close quarters. Also in the nebula family is the Orion Nebula. Visible to the naked eye as a blur in the sky near Orion's belt, it is one of the brightest and most accessible nebulae for observers of the cosmos. It occupies an area of sky 4 times larger than that covered by the full moon. Its size is around 24 light-years, but it's its proximity to Earth that makes it so visible. The Orion Nebula also owes its shimmering colors to hot young stars that emit intense ultraviolet light. This light excites the surrounding gas, mainly hydrogen, which then glows in different visible colors, giving the nebula its characteristic brilliance. This is the case for most nebulae, which are ideal zones for the formation of star clusters. Nebulae are nothing more than vast clouds of gas and dust in space. They contain all the elements necessary for star formation. When a nebula collapses under the influence of gravity, it creates regions of concentrated matter, known as protostellar cores. These cores are dense clusters of gas and dust, with high temperatures and pressures. Under these conditions, matter continues to accumulate and collapse until nuclear reactions are triggered in the core. This event marks the birth of a new star. When a large number of protostellar cores form within a nebula, they can eventually give rise to star clusters. The stars in the cluster thus share a common origin and are often gravitationally linked to one another. There are two types of cluster. Firstly, there are open clusters. These are clusters of young bright stars that are also massive and hot. Open clusters generally contain a few dozen to a few thousand stars and are scattered over a relatively vast area. Then there are globular clusters. These are clusters composed mainly of stars that are older and less massive than those in open clusters. Globular clusters typically contain hundreds of thousands to millions of stars and are also very dense. They owe their name to their spherical structure, which gives them a globular appearance. In the Milky Way alone, researchers have identified over 150 such clusters. One of the best known is undoubtedly M13, the large cluster in the constellation of Hercules. Located some 22,000 light-years from Earth, M13 has fascinated astronomers for centuries. Both massive and very compact, it's difficult to say exactly how many stars it contains. Estimates range from a few 100,000 to several million stars, tightly packed into a sphere, around 145 light-years in diameter. In the night sky, its apparent diameter is about half that of the full moon. The M13 cluster is also one of the oldest objects in our Milky Way. It is around 12 to 13 billion years old. It was therefore formed very early in the history of the universe, which was born around 14 billion years ago. The stars making up the Hercules cluster are predominantly low-mass, low-metallicity stars. In other words, they contain relatively small quantities of elements heavier than helium. There's also an interesting anecdote about this globular cluster. In 1974, M13 was chosen to send an interstellar message in the hope that one day an extraterrestrial civilization might receive it. Unfortunately, the chances of ever receiving a reply to this message are slim. So if there are no little green men in the Milky Way, we may have to look elsewhere. And why not in Andromeda? After all, it's the closest galaxy to us if we exclude dwarf galaxies. Located around 2.5 million light-years from Earth, Andromeda and the Milky Way appear to be closing in on each other at high speed. So much so that one day the two will collide to form a huge elliptical galaxy called Milkomeda. But rest assured, this won't happen for another 4 billion years. The Milky Way has a radius of around 52,850 light-years. Andromeda, on the other hand, has a radius of almost 110,000 light-years. It would contain around 1,000 billion stars. That's 2 to 5 times more than our own galaxy, which makes it 25% brighter than our beloved Milky Way. And yet, despite its impressive dimensions, Andromeda pales in comparison to the largest galaxy known to date, IC 1101. IC 1101 is a monstrous elliptical galaxy in the farthest reaches of the cosmos, 1 billion light-years away. Its diameter, mind you, is 6 million light-years. It's also home to over 100,000 billion stars, giving it a mass 2,000 times greater than that of the Milky Way. It's simply unimaginable. But in February 2022, another contender emerged to challenge for the crown. This galaxy is Alcyone, a cosmic monster 16.3 million light-years long. In reality, Alcyonia is not quite a galaxy, but rather a radio galaxy. This means that it emits radiation at very specific wavelengths. Radio galaxies are characterized by their intense emission of radio radiation, which comes from their active, supermassive nuclei. They are generally divided into two main categories: double-lobe radio galaxies and double-jet radio galaxies. The former have a Y or X-shaped structure, with two symmetrical lobes on either side of the central nucleus. Each lobe is made up of matter ejected at speeds close to the speed of light. They are the result of the presence of an active supermassive black hole in the middle of the galaxy. Double-jet radio galaxies feature narrow jets of matter ejected from the central nucleus at near light speeds. But unlike double-jet radio galaxies, they have no extended lobes. In any case, the behavior of radio galaxies is thought to be due to the presence of supermassive black holes at their centers. The latter actively absorb the surrounding matter, releasing an enormous amount of energy. This then manifests itself in the form of radiation of various wavelengths, including radio waves. These radio emissions come mainly from matter heated and accelerated by relativistic particle jets in the vicinity of the central black hole. This is why radio galaxies are an important object of study in astrophysics. They provide essential information on the processes of matter accretion around supermassive black holes. They also enable us to better understand the impact of these cosmic chasms on the evolution of galaxies and the universe on a large scale. Speaking of black holes, the one at the center of Alcyonia is not as gigantic as you might think. In fact, both Alcyone's stellar mass and the mass of its supermassive black hole are lower than those of other giant radio galaxies discovered previously. That said, it is still 100 times more massive than the black hole at the center of the Milky Way. So the largest known galaxy doesn't have the biggest black hole we've ever seen. But where is it hiding? The answer lies 700 million light-years away in a supergiant elliptical galaxy, the brightest in the Abell 85 cluster. This is Holmberg 15A, also known as Holm 15A. Around 3 times larger than the Milky Way, this distant cousin harbors at its center the largest world devourer ever discovered. Not a supermassive black hole, but an ultramassive one. 40 billion solar masses. The size of the associated event horizon, the limit beyond which nothing, not even light, can escape its pull, is simply unimaginable. Nearly 800 times the distance between the Earth and the Sun. That's 10,000 times the distance to the supermassive black hole at the center of our Milky Way. So far, we've seen that there are planets, stars, galaxies, and even giant black holes. We've also seen that stars can group together to form clusters. But what you may not know is that galaxies also form clusters. They entwine along a cosmic web to form complex structures of staggering size. These are known as supergalaxy clusters. Imagine a multitude of cosmic islands made up of billions of stars, grouped together in a colossal assemblage, like pieces of an immense cosmic puzzle. That's exactly what a supercluster is. To put it more simply, It's a large-scale cosmic structure made up of multiple galaxy clusters. And the clusters themselves are groups, sometimes containing up to several thousand galaxies. Superclusters can therefore group together dozens or even hundreds of clusters, creating a structure of colossal size. These cosmic giants extend over megaparsecs, an astronomical unit of measurement equivalent to more than 3 million light-years. Gravitational force is both the driving force and the cement of these astronomical constructions. Gravity pulls galaxy clusters together, forming a compact, massive whole that spreads across the fabric of space-time. This creates an environment where galaxies of all shapes and sizes cohabit, exchanging gas and stars and interacting gravitationally. Over time, superclusters continue to assemble, constantly drawing new galaxy clusters into their orbit. They also evolve through collisions with other superclusters, creating cosmic interactions of extraordinary complexity. Their discovery and study are of crucial importance to cosmology. They help us to understand the distribution of matter in the universe, as well as the dynamic forces that shape the evolution of galaxies over time. Now let's delve into the heart of these immense structures. Let's take a closer look at one of these superclusters that particularly arouses our curiosity and admiration, Laniakea. The name Laniakea comes from the Hawaiian word for celestial immensity. It's a fitting name given the sheer size of the structure. Laniakea extends over an area around 500 million light-years in diameter. That's almost 5,000 times the size of our own Milky Way galaxy. When we speak of Laniakea, we're talking about a supercluster of galaxies, a gargantuan collection of individual groups of galaxy clusters that span vast regions of space. And at the heart of this vastness lies our own galaxy, the Milky Way. Floating like a grain of sand on the edge of an infinite beach. Every point of light you see represents billions of stars, planets, gas, and dust. From up here, Laniakea looks like a brilliant constellation, its contours defined by the movements and attractions of the galaxies that make it up. Laniakea's interior is a complex collection of galactic filaments, dense clusters, and vast voids. These filaments are in fact cosmic highways, where galaxies migrate and interact under the influence of gravitational forces. It's a complex cosmic dance, in which each participant is linked by the invisible chains of gravity. The Milky Way, with its distinctive spiral, and our neighbor, the Andromeda Galaxy, are part of the Local Group, a cluster of galaxies belonging to the Virgo supercluster, itself part of Laniakea. Laniakea does not stand alone in the vastness of space. It is in constant interaction with other neighboring superclusters, such as the Perseus-Pegasus supercluster. These interactions on a cosmic scale shape the evolutionary landscape of the universe. But why are these structures so important to scientists? By studying superclusters, we can better understand how matter agglomerated after the Big Bang, and how galaxies formed and evolved. Ultimately, Laniakea is not just a supercluster of galaxies. It is a witness to cosmic evolution, a milestone in our understanding of the universe, and perhaps most importantly, our home in the great cosmos. And what's even more fascinating is that Laniakea itself is just one of many superclusters. It accounts for just 4% of the observable universe. our celestial immensity is actually connected to other superclusters, forming even larger structures, and an eternal celestial dance orchestrated by gravity. It was by conducting these studies on very large scales that astronomers were able to identify what is to date the largest and most massive known structure in the observable universe, the Great Wall of Hercules Boreal Crown, a fitting name for this gigantic galactic filament. Discovered by chance in 2013, following a gamma-ray burst mapping program, the Great Wall of Hercules is, so to speak, a supercluster of superclusters of galaxies. It measures almost 10 billion light-years by 7.2, making it 900 million light-years thick. It contains tens of thousands of galaxies and lies 10 billion light-years from us. By way of comparison, the diameter of the observable universe is 93 billion light-years. The Great Wall of Hercules therefore represents around 10% of the observable universe. Within the wall, galaxy clusters and superclusters are interconnected by filaments of hot gas. Since its discovery, researchers believe that other, potentially even larger, similar structures lurk in the darkness of the sidereal void, waiting to be discovered. Together, they would form the great web of the universe. If, from our perspective, galaxies and matter scattered throughout the cosmos seem to be scattered randomly, in a kind of infinite chaos, galactic filaments put this vision into perspective. In the end, things seem far more orderly than they appear at first glance. A bit like atoms coming together to form molecules on a microscopic scale. Other galactic fabrics have been discovered in recent years, such as the case of the Great Sloan Wall, which for a decade was considered the largest structure in the universe, before the Great Wall of Hercules Boreal Crown took its title. With a length of 1.3 billion light-years, it was a worthy challenger, no pun intended. It was spotted in 2003, thanks to data from the Sloan Digital Sky Survey, SDSS, spectroscopic survey. Even more recently, Boss's Great Wall came to the fore. More modest than the previous two, it is nonetheless an impressive network, comprising 4 superclusters of galaxies. It is estimated that at least 830 galaxies are trapped in its nets, giving it a mass equivalent to 10,000 times that of our own Milky Way. As discoveries progress, the galactic fabrics or filaments known as the wall lose their anomalous status. On the contrary, these formations are as widespread as stellar or planetary systems within galaxies. In fact, there are even stranger cosmic formations than clusters or walls. They're called superstellar bubbles. These are enormous cavities or spherical structures scattered throughout the interstellar medium. Stellar superbubbles are created by the explosive activity of multiple massive stars, notably supernovae and stellar winds. Supernovae are cataclysmic explosions that occur when a massive star exhausts its nuclear fuel and collapses in on itself, releasing a colossal amount of energy. Stellar winds, on the other hand, are constant ejections of matter from the surface of massive stars during their active life. Massive stars eject large quantities of matter, energy, and particles at high speed during their explosion and aging phases. The formation of superbubbles begins when these giants reach the end of their life cycle. These phenomena expel matter and energy into the surrounding space. If several massive stars form in a given region of a galaxy, their combined explosions and ejections can create a huge cavity in the interstellar medium, forming a stellar superbubble. Inside these superbubbles, the gas expelled by the stars mixes with the surrounding interstellar gas, creating dense hot regions. The shock waves generated by the explosions propagate through the interstellar medium, compressing the surrounding matter and promoting the birth of new stars. Superbubbles can extend over hundreds to thousands of light years. They are therefore just one of the many forms that large-scale cosmic structures can take. Once again, they reflect the diversity of phenomena and creative processes that can take place within our universe. Magnificent cataclysms which give rise to the most terrifying explosions, but also to the most beautiful creations that man can observe. Far, far away, lost on our blue planet, we'll continue to scan the skies in search of these events that are beyond our comprehension in an attempt to unravel their secrets. Ridiculous as we are in the face of cosmic immensity, our thirst for discovery, but perhaps also our natural ego, leads us to believe that one day infinity will reveal its secrets to us. Throughout our journey, we've been able to admire many of the cosmic immensities that dot our universe. But however large and imposing these entities may be, they all remain measurable. This raises a crucial question. Does the universe have an end? Is it just a huge bubble filled with galaxies, stars, black holes, and other stellar objects? And if so, what surrounds this bubble? Is it nothingness or something even more vast? As soon as we take the slightest interest in the cosmos, all these dizzying questions inevitably come to mind, to the point of making us feel uneasy, because these questions confront us with the limits of our own understanding. We may understand the principle of infinity, but we can't visualize it clearly in our minds. It's as if we're missing some key to understanding. An emptiness that means we can't put our finger precisely on certain concepts to grasp all their nuances. And then comes the ultimate question. Are the secrets of the universe meant to be understood by man? Or are they, by their very nature, forever inaccessible to us? Taking the thought process a step further, we might even wonder whether understanding all the workings of the world around us would make our existence more meaningful. After all, isn't it this perpetual lack of understanding and the mysteries that lie before us that drive us to live to discover them? It's up to you to find the answer. Perhaps it will lead you to other questions, which will continue to fuel the flame of your curiosity. That burning desire to seek the truth, to understand how things work. In the end, perhaps that's the greatest strength of the human race.